lesson, I'm going to show you how to complete and use tree diagrams to answer probability questions. So in the first example, it says a bag contains 5 red balls and 3 green balls. A ball is drawn and then replaced before a ball is drawn again. Draw a tree diagram to show all the possible outcomes. Then we have to find the probability that 2 green balls are drawn, then 1 green and 1 red ball is drawn, and lastly, at least 1 red ball is drawn. Okay, so let's just have a look at the tree diagram over here, and what we need to do when we complete a tree diagram is fill in the probabilities on each of the branches, okay? So R just stands for a red ball and G stands for a green ball. And the first 2 branches in the diagram represent the first ball that's drawn, okay? So we need to write down the probability that a red ball is drawn to start with, okay? So there are 5 red balls and there are 8 balls altogether. 5 plus 3 is 8. So the probability of taking a red ball is going to be 5/8, okay? The probability of taking a green ball is going to be 3/8 because there are 3 green balls and again there are 8 balls altogether. Okay, so notice how the denominator is the total number of balls. Now in this question it says that the ball is replaced. So that means you take the first ball but then you put it back before you take the second one. So the probabilities won't change, okay? The probability of taking a red ball on the second try is going to be the same, 5/8. And likewise for green, it's going to stay the same, it's 3/8. Okay, so all the probabilities for red and green remain unchanged, okay? So now we filled in all the probabilities, the tree diagram is finished, okay? Now we're going to use the tree diagram to answer the probability questions. And in the first one, we have to find the probability that 2 green balls are drawn. So remember, G represents a green ball. So the route we're going to follow on the tree diagram would be this one, okay? A green followed by a green. Now what you have to do with the probabilities is multiply them together. So it's 3/8 multiplied by 3/8. If you can remember that when you move along the branches like that, you're always multiplying the probabilities, that will help you, okay? So if we calculate this, 3 multiplied by 3 is 9, 8 multiplied by 8 is 64, so that is the probability of taking 2 green balls, okay? Now on part 2, we have to find the probability that 1 green and 1 red ball is drawn, and it doesn't specify which order they're taken in, okay? So it could be a green ball followed by a red ball or a red ball followed by a green ball. So we have 2 different scenarios that we have to consider this time. So let's just start with the first scenario. So a green ball followed by a red ball. So a green probability here would be 3/8 and then a red ball here would be 5/8. So remember, you're multiplying the probabilities together. So it would be 3/8 multiplied by 5/8, okay, which is 15 out of 64. Then if we look at the other scenario, a red ball followed by a green ball, this time we're going to follow this route in the tree diagram, okay? Red followed by green. So we need to multiply 5/8 by 3/8, okay, which is actually going to give you the same answer. Okay, because they're the same fractions, just the other way around. So it's 15 out of 64. Okay, so we've got our 2 same probabilities for these 2 different scenarios. What you have to do afterwards is add them together, okay? So 15 out of 64 plus 15 out of 64, which is 30 out of 64. And if you simplify that, divide top and bottom by 2, you get 15 out of 32. Okay, so that's the probability. Now, I would try and remember that when you have different scenarios like this, you always add them together. So when you're moving along the branches, you're multiplying, okay, whichever way you go. And then when they're different scenarios, you're adding in between, okay? So the last one says we have to find the probability that at least 1 red ball is drawn. So we could have 2 red balls that are drawn. We could have a green followed by a red, or a red followed by a green, okay? All of those scenarios show at least one red ball that is drawn, okay? I'm going to show you two methods for the last one. So the first method is just like in the second question, okay? We're going to calculate the probability for each scenario and add them together, and then I'll show you a quicker way afterwards, okay? So if we take the first scenario, a red ball followed by a red ball, that's going to be this way on the tree diagram. So 5/8 multiplied by 5/8, which is 25 out of 64. Then we know a green followed by a red, we did it here, okay? It was 15 out of 64. And we also did a red then a green, it was here, 15 out of 64. Okay, and remember what I said before, whenever you're considering different scenarios like this, you have to remember to add those three probabilities together. Okay, so if you have 25 out of 64 plus 15 out of 64 plus another 15 out of 64, you get 55 out of 64, okay? So that's the answer to the last one. And now I'm just going to show you another method which I think is a little bit quicker. So another way to find the probability that at least one red ball is drawn would be to subtract from the number 1 the probability of a green ball followed by a green ball. Now, the reason I'm using the number 1 is because the sum of probabilities always equals 1. And a green followed by a green is the only scenario which doesn't include a red, okay? So what we're doing is subtracting from the sum of probabilities the only scenario that doesn't have a red ball. So we're minusing what we don't want, because that will leave us with what we do need, okay? So if you subtract 1 minus a green followed by a green, we worked out in part 1, so 9 out of 64, it gives you 55 out of 64, which is the same thing that I wrote down over here, okay? So it's exactly the same answer, just a different way of working it out. This method is particularly helpful when there's a big question. Imagine there were 3 different colours here, okay? This method could be quite lengthy in some questions, so it's useful to know this one as well. In this example, a bag contains 5 red balls, 3 blue balls and 2 yellow balls. A ball is drawn and not replaced. A second ball is drawn. Find the probability of drawing 2 red balls, 1 blue ball and 1 yellow ball, 2 balls of the same colour, and then 2 balls with different colours, okay? So before we answer these questions, we're going to fill in the probabilities on the tree diagram. In this question, there are 3 different colours, red, blue and yellow, so there are 3 separate branches here, okay? Red, blue and then yellow. Remember, these branches at the start are when you draw the first ball, and then these branches further along are when you draw the second ball. Now let's consider the first branch here. So this is as if we take a red ball on the first go. The probability of taking a red ball on the first go is going to be 5/10. 5 because there are 5 red balls, and it's out of 10 because there are 10 balls altogether. 5 plus 3 plus 2 is 10. The probability of taking a blue ball is going to be 3/10 because there are 3 blue balls and again 10 balls altogether. And then here the branch, as if we're taking a yellow ball on the first go, is going to be 2/10. Okay, so the next part is where we have to be careful, because in this question it says a ball is drawn and not replaced. So when you take the first ball out here, you don't put it back in. So imagine you've just taken out one of the balls. There aren't 10 balls anymore, now there are 9. So each of the denominators for the probabilities on these branches is going to be 9, okay, instead of 10. Okay, so it's the same all the way through there. Okay, so if we just go back to the top, so the scenario as if we have just taken a red ball up here, okay? The probability of taking another red ball is going to be 4/9, because this is as if we've just taken out a red ball. So if you take away 1 from 5, you're left with 4 red balls. The number of balls for blue and yellow, however, won't change, because here we've taken out a red ball, So the number of blue balls is still 3 and the number of yellow balls is still 2. So the probability for a blue ball here would be 3/9 and for yellow it would be 2/9. Now if we consider the middle branch, so this is as if we've just taken out a blue ball. Now we've taken out a blue ball, which means the number of red balls and yellow balls remains the same. So the probability for a red ball here will be 5/9 and for yellow it will be 2/9. The only one that changes is the number of blue balls. And if you take away 1 from 3, you get 2. So the probability of taking a blue ball on the second go would be 2/9. Okay, and then for the last branch down here, this is as if we've taken out a yellow ball. So if we take out a yellow ball, the number of red and blue balls will stay the same. So there are still 5 red and 3 blue. So I can write 5/9 for red and 3/9 for blue. But the number of yellow balls has decreased by 1. So now there's only 1 yellow ball. So the probability of taking a yellow ball on the second go is 1/9. Okay, so that's the tree diagram completed. Now we're going to try and find the probability of drawing 2 red balls. So the route we need to follow on the tree diagram is here. Okay, a red ball followed by a red ball. So we need to take these 2 probabilities here, and remember you have to multiply them together as you travel along the tree diagram. So we're going to take 5/10 and multiply it with 4/9. Okay, so if we work this out, 5 multiplied by 4 is 20, 10 multiplied by 9 is 90, and then you can simplify this fraction by dividing top and bottom by 10, so it simplifies to 2/9. So there's the first one. In number 2, it says work out the probability of drawing 1 blue ball and 1 yellow ball, and it doesn't specify the order in which this happens. So it could be a blue ball followed by a yellow, or a yellow followed by a blue. Now if we take the first one, a blue followed by a yellow, that would be here, 3/10 multiplied by 2/9, a blue followed by a yellow. So 3/10 multiplied by 2/9 is going to give me 3 times 2, which is 6, 10 times 9, which is 90, so the answer is 6/90. Okay? Now if we take the other way, so a yellow followed by a blue, this time I'm going to go this way, so a yellow followed by a blue, so it's going to be 2/10 multiplied by 3/9. Okay, and if you multiply these together, you get exactly the same thing. Okay, so it's the same probability for each. Now remember what I said in the previous example. When you have 2 different scenarios, or more than 2 scenarios, you have to add the probabilities together at the end. You have to add the different scenarios together. So we're going to add 6 out of 90 to 6 out of 90, which gives us 12 out of 90. Okay, remember, they have a common denominator, so you can add them together straight away. The denominators stay the same. 6 plus 6 is 12. Okay, so the answer is 12 out of 90, and you can divide both of these by 2, so you get 6 out of 45, and then you can divide by 3, so it simplifies to 2 out of 15. Okay, so that is the simplified probability for part 2. Now, on part 3, it says find the probability of drawing 2 balls of the same colour. So there are 3 different scenarios to consider. It could be a red followed by a red, a blue followed by a blue, or a yellow followed by a yellow. Well, we already did 2 red balls up here. Remember, it was 20 out of 90. Then if we work out a blue followed by a blue, that would be along these branches here, so 3/10 multiplied by 2/9. And if I work that out, I get 6 out of 90. And then a yellow followed by a yellow would be 2/10 multiplied by 1/9. Okay, and that would be 2 out of 90. Okay, now remember we've got 3 different scenarios here, so you have to add these 3 probabilities together. 20 out of 90 plus 6 out of 90 plus 2 out of 90. And I purposely left the denominator as 90 each time without simplifying so that I could add those fractions straight away at the end. They have a common denominator, so the denominator is 90, and then 20 plus 6 is 26, plus another 2 is 28, okay? And these are both even numbers, so I can divide them both by 2, so it simplifies to 14 out of 45, okay? So on to the last part. It says find the probability of drawing two balls with different colours. So if we were to use this same method, it would be very time consuming, okay? Because two balls with different colours could be red then blue, red then yellow, blue then red, blue then yellow, yellow then red, yellow then blue. There's so much to work out, okay? It's very long and it's easy to make a mistake when you have that much working out to do. So you can use that other method I showed you before. What you can do is subtract from the number 1, the sum of probabilities, everything that you don't want. So what we would subtract from 1 here would be everything with the same colour. And I actually just worked that out in part 3. Okay? If you subtract all the scenarios where the balls are the same colour, so 1 minus 2 reds, take away 2 blues, take away 2 yellows, okay, it will leave you with all the other scenarios, which would be when the balls are different colours, okay, all those other scenarios I just talked about on the tree diagram. So if we subtract 14 out of 45 from 1, that's going to give us 31 out of 45, and that was much quicker than multiplying all those different scenarios and adding together, okay, it was much faster. Okay, so do try and get used to using that method if you can.